In the early hours of June 30th, 1908, an unimaginable force tore through the skies above Siberia, leaving behind a mystery that still baffles scientists today. What caused the Tunguska explosion? An event so powerful that it flattened over 80 million trees and sent shockwaves across the globe? Could it have been a meteor, a comet, or something far more extraordinary? The day began like any other for the remote communities living near the Tunguska River. But at around 7:14 a.m. local time, everything changed. A dazzling blue-white fireball streaked across the sky, followed by an ear-splitting explosion that was heard as far as 500 kilometers away. Eyewitnesses described the moment as otherworldly, with the sky seemingly splitting in two. A blinding flash of light lit up the early morning, followed by a massive fireball streaking across the heavens. Moments later, an ear-splitting explosion shattered the tranquil Siberian wilderness, unleashing a force so powerful that it knocked people off their feet, even at distances of tens of kilometers from the epicenter. Some recalled feeling an intense heat wave, as if the sun had descended upon them, followed by a deafening roar that echoed across the vast taiga. The shock wave that followed was so immense it circled the globe twice, according to barometers at weather stations thousands of kilometers away. On the ground, entire villages felt the tremors, with residents thrown violently to the ground. Windows shattered, wooden houses creaked under the strain, and terrified locals believed the world was ending. One man living 60 kilometers from the blast was reportedly flung several meters into the air, landing unharmed but stunned. The explosion flattened an area of forest equivalent to approximately 2,150 square kilometers, roughly the size of a major metropolitan city like Tokyo or Los Angeles. Trees were charred, stripped of their branches, and laid out in a peculiar radial pattern, pointing away from the blast's epicenter. Up to 30 kilometers away, the intense heat scorched tree trunks, leaving them standing like eerie, blackened sentinels amidst the devastation. Scientists estimate the energy released by the explosion to be between 10 and 15 megatons of TNT, over 1,000 times the power of the atomic bomb dropped on Hiroshima. Despite the sheer magnitude of the blast, one of the most perplexing aspects of the Tunguska event is the absence of an impact crater. This anomaly has puzzled researchers for over a century, as traditional meteorite or asteroid impacts typically leave a distinctive crater at the site of collision. Instead, the landscape bore no direct evidence of a celestial object touching down. At the time, Siberia was one of the most isolated regions in the world. It wasn't until 1927, nearly 2 decades later, that a Soviet scientist, Leonid Kulik, led the first scientific expedition to the Tunguska site. What they found was astonishing. Trees in the central area were stripped of their branches and bark, yet no impact crater or meteorite fragments were present. Kulik hypothesized that a meteorite had exploded in midair, but he couldn't provide conclusive evidence. Over the years, numerous theories have been proposed to explain the Tunguska event. The most widely accepted is the airburst theory, which suggests that a meteoroid or comet entered Earth's atmosphere at an exceptionally high speed, likely between 15 and 40 kilometers per second. The object, estimated to be 50 to 60 meters in diameter and weighing several 100,000 tons, was composed of either rock, metal, or ice, common materials for meteoroids and comets. As the object entered the Earth's atmosphere, the immense pressure of atmospheric resistance caused it to compress and heat up dramatically. At such high velocities, friction between the object and the air created a glowing fireball, producing temperatures of thousands of degrees Celsius. This process, known as ablation, caused the outer layers of the object to vaporize, forming a bright streak across the sky that witnesses described as a column of fire or a second sun. However, the object's rapid deceleration, combined with the growing pressure and heat, created a catastrophic buildup of energy. At an altitude of approximately 5 to 10 kilometers, 3 to 6 miles above the Earth's surface, the meteoroid or comet reached its breaking point. The tremendous pressure and heat caused the object to explode mid-air in what scientists call an airburst. This explosion released an estimated 10 to 15 megatons of energy, equivalent to the detonation of 1,000 Hiroshima atomic bombs. The blast generated a powerful shock wave that expanded outward, flattening trees, scorching vegetation, and sending shock waves through the atmosphere. The altitude of the explosion explains why no impact crater was formed. The object disintegrated entirely in the atmosphere before it could reach the ground. The explosion's energy was directed outward and downward in a radial pattern, creating the characteristic flattened forest observed at Tunguska. The heat from the explosion ignited fires and scorched tree trunks, leaving behind a devastated landscape. However, skeptics argue that no significant fragments have ever been recovered to prove this conclusively. Other theories range from the plausible to the outlandish: a comet made of ice, a natural gas explosion, or even an alien spacecraft crashing into Siberia. Some have even speculated about a rare phenomenon known as an antimatter collision or a microscopic black hole. While fascinating, these theories lack substantial scientific evidence compared to the airburst hypothesis, which aligns closely with modern observations of similar phenomena. In recent decades, advancements in technology have allowed scientists to revisit the Tunguska mystery. Simulations now support the idea that a stony asteroid, likely composed of silicate material, caused the explosion. The asteroid likely disintegrated upon entering the atmosphere, creating a shock wave that flattened the forest below. This explanation aligns with other documented airburst events, such as the Chelyabinsk meteor explosion in 2013, which injured over 1,500 people but left no crater. Even with modern science, mysteries remain. Why have no definitive fragments of the object been found? Could the Tunguska event have been a rare cosmic event we've yet to fully understand? What we do know is this: the Tunguska event serves as a stark reminder of the unpredictable power of our universe. In a world of satellites and space exploration, how prepared are we for the next celestial encounter? More than a century has passed since the Tunguska explosion, yet its mystery remains unsolved. Was it a fiery meteor that exploded in the skies, a rare cosmic phenomenon, or something even more extraordinary? While science provides plausible answers, the allure of the unknown keeps us searching, questioning, and imagining. The Tunguska event is more than just a story of destruction. It's a reminder of how interconnected we are with the cosmos, and how even the most remote corners of Earth can become the stage for an extraordinary celestial drama. Thank you for joining us on this journey through history and mystery. If you enjoyed this exploration, don't forget to like, subscribe, and hit the bell icon to stay updated with more captivating tales from beyond borders. Together, let's uncover the stories that shape our world and beyond.